SWA students will be able to solve systems of equations by graphing. Okay, so we're going to solve systems of equations. So what does system mean? Okay, we've been graphing a lot of equations, haven't we? We've basically been doing that the majority of the chapter, right? We've been graphing tons of stuff. So a system of equations is a set of two or more linear equations containing two or more variables. For our purposes, we will use two equations with two variables each. X and Y typically. Now, systems of equations are used to represent situations and solve problems related to consumer economics, finance, geometry. So these do have some real-world applications, by the way, in case you're wondering. Like I said, like business and finance, okay? So we're going to work on solving them by graphing. Next chapter, we're going to go over systems quite a bit and solving them a lot of different methods. Right now, we're just going to be concerned with the graphing because that's what we've been doing a lot of, right? Okay. So graphing. If two different lines are graphed, they're always going to meet at one point. Unless they're parallel, right? Because then they never meet, right? Or if they're the same line. Okay? That'd mean they just overlap each other. So the point where they meet is called the intersection. Think of like two streets, right? Two streets meet and it's like an intersection. Okay? Same idea. So either two streets are parallel, they never intersect, or two streets intersect, they do cross, or two streets are in fact the same street. Okay? They're just actually the same street. Because a street wouldn't intersect itself, would it? But everywhere on the street is also on that same street, so to speak. Okay? So we write the intersection of these two lines, okay, or the street, for example, as an ordered pair, x comma y. Okay? So we're doing a ton of stuff with ordered pairs all chapter. X comma y, x comma y, x comma y. Okay? Questions on that? Alrighty. So we have some steps for solving these, okay? So we're first going to put both equations in a slope-intercept form if necessary. Now, if we look here on number 1, we see this little brace thing, okay? This brace thing here just tells us that these two equations are in a system. It just says, hey, these two go together. Okay, that's all it's saying. It's nothing more than saying these two go together. Does that make sense? Alrighty. So we have y equals negative 2x minus 1 and y equals x plus 5. These are our two equations. Step 1, put them both in a slope-intercept form if necessary. Do we have to do step 1 here? No, why not? It's already done. Dope. Step 2, graph the first equation. And this time, we want to use a ruler to draw the line, okay? Or some sort of straight edge, okay? A straight edge can be your phone. A straight edge can be another pencil. A straight edge can be a ruler. It can be a textbook, a notebook, a laptop. It can be lots of things. I would encourage you to grab your own straight edge, and if you need a straight edge provided for you like a ruler, raise your hand and Mrs. Haswell will pass out some rulers. It was a good lesson for this today, Mrs. Haswell. Okay, so raise your hand and Mrs. Haswell will pass out some rulers there in the Tuesday spot. I think Olivia raised her hand too, but did you not? You did. Do you need them still? Okay. You seem very unenthusiastic about getting a ruler. Okay, by the way, I should say this. The rulers aren't toys. Don't play with them. Okay? Yes, exactly. Don't do that.
In third grade, I would always go home with bruises on my legs just from hitting my legs.
See?
Or like just,
you know,
like...
Well, don't touch multiple of them.
I know, but like... I don't feel good, I swear. Look at you. Look at you. That's probably all you, like... I know. I literally...
I'll get on my sore leg.
Okay.
All right, so we're going to graph the first equation. So y equals negative 2x minus 1. Well, how do I graph this equation? We can make a table, but what was our faster way than that? Make our slope negative 2 over 1. What else can I pull out of that equation?
Wait, -1.
-1. What's our -1? What's that called? Something we start with, we begin with B. Our y-intercept. So where am I going to go with my -1 here?
To the left.
Not quite.
What? To negative.
Down. It's on the y-axis. It's the y-intercept, so it's on the y-axis. Okay? So we're going to put a -1 on the y-axis. Then we use our slope to make one more point or two more points. Okay? We'll make two more points. Mason.
Why is it? How does it be -2 over -1?
Great question. So in order for it to simplify to -2, we'd have to have it over a positive one. If it was over a -1, it would simplify down to -2, or +2, excuse me. That make sense?
Yeah.
Great question. So -2 over +1, okay, please don't play with the rulers, okay? So -2 over 1, we're going to go to what direction? Down. One what direction?
Right.
To the right. Now I can do the same thing again. I can go 2 down and 1 right again, or I can reverse it. We don't really care which. Okay?
Have to reverse it? Like, is that?
You don't have to reverse it.
Oh, two.
I've just been getting us in the habit of it, so that way we know we can. Okay, but you can go either the same way again, or you can reverse it. So now I want us to use a ruler to connect these.
Oh.
And go ahead and keep going with your line.
Keep going.
Yep. So like, look at mine. Connect it and keep going. So that's why we're using a ruler or a straight edge to make sure we're precise. And you can keep going and you'll follow that same path. Does that make sense? Okay.
I like your straight line, Mr. Costa.
Thank you. You know, I'm pretty proud of that, Tobin.
Yeah. Looks better than all the other ones.
It actually does, though. I think it does. Okay?
I think you do better on the iPad with straight lines.
I probably don't do worse.
Well, I think that it's not just you. The person is not straight lines.
Oh, it might be a little bit of both.
Well,
But I appreciate it. All right, so did we graph the first line? Yep. So what's step 3 say?
Not the second one.
Graph the second line, okay? But say it with some enthusiasm, okay?
Yeah, the second one.
Perfect, okay? So, what's my m and my b for my second equation?
0 and 5.
It is 5 for b, but my m is not 0.
1 over 1.
1, or 1 over 1. There's secretly a 1 in front of the x. If there was a 0, we wouldn't see the x. So which one of these do I use first? The slope or the b, the y-intercept? The b. We begin with b. So where do I go 5?
Over 5.
Up. It's on the y-axis. It's the y-intercept. It's where it crosses the y-axis. And now I can go what direction?
Up 1 over 1.
Up 1 over 1 where? To the right or left?
Right.
Right? I can also go down 1 and left 1. And I connect these with a straight line.
I get it.
Okay. So, once we have that graphed, we are done with step 3. So we're on to step 4. Write the point where the two lines meet, or intersect. This is the solution. So where do they meet?
Nowhere.
4 and 2. 3. Oh, hang on.
Oh, what?
-2.
Negative 2, 3.
Negative 2, comma 3, x, comma y.
What?
Negative 2, comma 3, or x, comma y is where they meet. They meet 2 to the left, 3 up.
Oh.
Negative 2, 3 is where they meet. What?
Is that why you're using these?
Why? Go ahead. Like, why would it be important to use those?
Make it accurate.
To make it accurate. Because if we didn't use it, would we be able to be off just even a little bit? And would that change our answer?
Yeah.
It would change our answer like crazy. Okay? Negative 2, comma 4 would be different than negative 2, comma 3, but we might get that if we don't use a straight edge. Okay? So you don't have to have a ruler as a straight edge. Like I said, you can use a notebook, a folder, a textbook, a laptop, a phone, you name it. Okay? There's lots of things that can be used as a straight edge. So even if you're outside of class, you don't have a ruler, you can use something else as a straight edge. Okay?
So technically he's saying don't come here and have an excuse.
Boom. What Laney said is basically I'm saying don't come here and have an excuse, and I agree. Don't come here and have an excuse saying, oh, I didn't get done, I don't have a ruler. Psh. You use one of the other things.
I will do it.
Okay, check. What's it mean to check? Well, if it's a solution to the system, this is the one point that should work in both of them. This is the one point that should work in both of them. Any other point we see won't work in both of these equations. Only this one will, because that's where they intersect. Okay? So if we plug this into the first equation, it'll work. And if we plug it into the second equation, it'll work. But we're going to check that real quick, just to verify. So for our checking, I'm going to take my y equals negative 2x minus 1, and I'm going to plug in negative 2 for which variable? I'm going to plug in negative 2 for x. Very good. I'm going to plug in 3 for which variable? Y. So I'm going to plug in 3 equals negative 2 times negative 2 minus 1. So go and do that with me. So plug in the 3 for y and the negative 2 for x. And go ahead and do that with me. You guys have a little bit more room than I do, okay?
Ready?
Okay. So what is negative 2 times negative 2?
Positive 4.
Positive 4. Hey, does 3 equal 4 minus 1?
It's 3.
Yeah. So does 3 equal 4 minus 1?
Oh, yeah.
Yeah. So that first one checks out. But now I have to check it in the other one just to make sure it works in both. Just because it works in one is not enough. That means it's a solution to the first equation. But we need it to be to the system, aka every equation in the system.
Mason.
So y equals x plus 5. Can somebody tell me what I would write now? Instead of y and x, I would write what and what?
You would put
Yep.
3 equals negative 2 plus 5.
3 equals negative 2 plus 5. Hey, what is negative 2 plus 5, guys?
3.
3. Does 3 equal 3?
Yes.
So does it work for both?
Yes.
Yep.
Yep.
Oh. So negative 2 comma 3 was a solution, okay? Now, am I going to make you guys check this maybe on a test or on your worksheet?
Yep.
No, I'm not going to make you check it. But is it a good tool to make sure you got it right?
Yeah.
No.
Yeah. Just saying. Okay?
I know I have it right.
Okay, because we did it together. Okay?
Oh, there's the one that says, oh, I
Okay.
did it wrong.
I'm confused on how we got the point.
Great question. How we got the point. So, any solution for this blue line, for this first equation, is just going to be anywhere that's on the point, right? We said that before. A solution to a line is anywhere where it's on the point. We said that back in section 4.4. Now and then we said, okay, well, any solution to the red line, this bottom equation, will be anywhere that's on the line is a solution. You could plug in any number that's on this line. You could even plug in negative 7 comma negative 2. I just picked one randomly. And you could put it into this bottom equation and it'll work. Okay? Any point on this. Just like in the blue one, you can put any point on this and it'll work in the top one. But where they intersect is negative 2 comma 3. This is where they both are true. So this is the one point, negative 2 comma 3, where they both work. Where it works for both of them. Does that make sense? Okay? Because this point down here, negative 7 comma negative 2, is true for the top, but not for the bottom. And this point down here, 0 comma negative 1, is true for the, that one's true for the top. The red one is true for the bottom, I mix those around. But does that make sense, though, where the intersection is the solution to both? Okay. It's like saying, hey, where do two streets in town meet up? Kind of thing. Where do they both exist at? And it's at their intersection. Okay, same idea. Okay, Olivia. Yes, good luck. Okay, let's look at number 2. Okay? Number 2 here. Negative x plus 3y equals negative 9. 2x plus y equals 4. What's our first step? We have these 4 steps. What's our first one? Make them in slope-intercept form. On this one, do we need to do that?
Yes, sir.
Yes, we didn't need to on our first one. We need to on this one. So this first equation, where we have negative x plus 3y equals negative 9. What do I have to do to get that in this slope-intercept form? Aiden, what do I have to do to get that in slope-intercept form? Negative x plus 3y equals negative 9. Might be a good idea to make sure we're writing all this down, right? Okay. Aiden, can you help me out with what my first step would be? Abby, put it away, please. You don't know what's happening with y. We're trying to get y by itself so it's in the slope-intercept form. What's happening with y, Aiden? You can't see anything that's happened with y in this equation? What's this mean if it's next to it? It's being what with the 3? Multiply with the 3, and what else? Yep, and which one do we want to undo first? Do we like to undo addition? We like to undo the negative x. So how do I get rid of negative x? I would add x. Very good. And we're trying to get y by itself, so it's in our slope-intercept form. Go and write that down, okay? Negative x plus x is 0. 3y equals x minus 9. Once again, the x stays positive, the 9 stays negative, and I'm going to put the x first. Abby, what would I do now?
So you would divide 3 on both of them, and then negative 9 divided by 3 would be negative 3, and 1 divided by 3 would just say 1 divided by 3.
Yeah, so it just says 1x divided by 3. So now it's in slope-intercept form, right? So this can help me by saying, okay, what's my m and what's my b?
Is x over 3.
X over 3. What's secretly with that x, though?
1.
1. So it's what over 3? 1 over 3 is secretly my m. What's my b? Negative 3.
Does it matter which one you graph first? Should I just graph the second?
Great question. It really doesn't matter which one you graph first, okay? Now we're halfway done with the first step. This first step can be a long one. We need to get both equations in slope-intercept form. Is the second equation in slope-intercept form? No, so we need to do that still. So 2x plus y equals 4. Tobin, what would I do first to get this equation in slope-intercept form?
You would do.
What's happening with y?
It's being added.
With 2x, right?
Yeah.
How do I undo that?
You.
Okay, so let's subtract 2x. That's always our question, is what's happening with our variable? So 2x minus itself is 0. Y equals negative 2x plus 4. Is y by itself now?
Yeah.
Yeah, so it's in slope-intercept form. So what's my m and my b, Tucker?
Your m would be
Sorry, I didn't hear what you said.
I can't see that.
Okay. Y equals negative 2x plus 4. Nope, not my m. It's y equals mx plus b. Yep, negative 2 or negative 2 over 1. And what's my b going to be, Tucker? That'd be 4. So now, did I do my first step, put both equations into slope-intercept form?
Yeah.
Yes. So now, what am I supposed to do for steps 2 and 3? Graph the equations. And Delaney asked, does it really matter which equation we graph first? The answer is no. Okay, I want you guys to graph these. Once you have them or have questions, raise your hand.
I got a question.
Here. So we'll do the orange one first, the second one first, just because Lainey asked if it mattered and I said no. So the B is 4. We begin with 3, so I'm going to go up 4. Then I'm going to go down 2 into the right 1. I'm going to do it again, down 2 into the right 1. Okay? Now, here's something you can kind of do to help yourself make sure you're even more accurate. The more points you have, the more accurate you're going to be, okay? So I can go down 2 to the right 1. So if you're worried about being accurate or not, you can keep creating more points and just keep going down 2 into the right 1 or up 2 into the left 1 just to make sure you're accurate, okay? And so now I can connect these. Okay. And then I can do my purple one. start at negative 3, and I go up 1 to the right 3, up 1 to the right 3, and hey, do we maybe see an overlap right away?
Yeah.
Okay. Okay. Where's my intersection at?
3, -2.
3, comma, negative 2 is 3 to the right, 2 down. Now, could we check it? Yes. Do I make you?
No.
No, the choice is yours, okay? So you can choose to and make sure you get it right, or you can choose not to and risk getting it wrong. Does that make sense?
Yes.
Okay. Continuing on. Identifying a solution. This is going to be very similar to what we've done. This is basically the check part. So we have 3 steps to this. We're going to plug it in for plug in the point for x and y of the first equation. We're going to plug it in for the second equation, and we're going to see if it works in both. If it only works in one, is it a solution of the system? No, it's a solution for one line. But for the system, we need to be a solution to everything. So on this example 1, we're asked to, hey, tell whether the ordered pair is a solution of the given system. So is 4, 1 a solution of the system? Well, if it is, it would work in both equations. So how would I test to see if it works in both equations? Plug it into both equations, one at a time. So can somebody help me plug it into this first one? Hannah, thank you for volunteering. Help me plug it into this first one.
Okay. 4 plus 2 in parentheses 1.
Oh, I love it. Equals 6. Okay, so we're gonna plug this one in, and we're gonna check it. Okay. Now before we go through and finish checking this one, this time I'm gonna have you guys plug in the other one too. Typically, you probably just go through one at a time, but I want you guys to try checking it. Okay. Now, who wants to help me with the second equation, plugging it in? Okay, Aiden, go ahead. You raised your hand.
4 minus 1 equals 3.
4 minus 1 equals 3. I want you guys to check both of these equations and determine whether or not 4, 1 is a solution to the system, okay? So when you have it or have questions, raise your hand. 4 plus 2 times 1 equals 6. What is 2 times 1? 2. So 4 plus 2. Does 4 plus 2 equal 6, guys?
Yeah.
Yeah, that checks out. We would have 6 equals 6, and that is true. In the blue equation, 4 minus 1 equals 3. What's 4 minus 1?
3.
Does 3 equal 3, guys? It checks out. So, is my answer yes or no?
Yeah.
Yes, it is the solution to the system. I want you guys to try number 2. When you guys have number 2 or have questions, raise your hand. So if we just did this in one equation, we might think this works, doesn't it? Okay, so if we do this first one, x minus 2y equals 4, and I plug it into there and I say, okay, 2 minus 2 times negative 1 equals 4. I have 2, negative 2 times negative 1 is positive 2, so 2 plus 2, does 2 plus 2 equal 4?
Yes.
Yeah. So I'd say, I might just stop there and say, hey, this works. But what's the danger in that?
It might be wrong.
It might be wrong, because the other one might not work. What, mine it? Okay, so we have to try the second one too. 3x plus y equals 6. Okay, well 3 times 2 instead of 3 times x, plus negative 1 instead of plus y, equals 6. Well, 3 times 2 is 6. Does 6 plus negative 1 equal 6, guys?
No.
No. So what's our answer? No, this doesn't work. So that would be like earlier, guys, on on our graph. If I picked like this point, okay, on this red graph, can everyone see where I'm scribbling?
Yeah.
Okay, if I pick like there, okay, that'd be like choosing that. It works in one, but not for the other. Does that make sense? Okay. Yes. Good luck.
Have fun.
Okay. A little bit of notes left on this page, and then we're on to 2 more problems. Sound Gucci? Gucci, okay? When I say Gucci, you say gang. Gucci. Gucci. Attention. If 2 lines are parallel, they have how many solutions? Do we think?
1,
1. 0.
2.
They're going to have 0 solutions. A solution is where they cross, right?
Yeah.
Will parallel lines ever cross?
No.
No, they don't cross, so they don't have any solutions. They don't intersect anywhere. They don't share any points. If I look at the flag in the back of the room, or in the side of the room, or in the other back of the room, or on the other side of the room, I like flags. What might you notice about the white stripes? Will 2 of those white stripes ever intersect? No, they're parallel. They don't have a solution to their intersect. That's their intersection. Is they don't intersect. Okay,
Well, am I supposed to have this?
but it doesn't.
Get out onto it.
No. If 2 lines are coinciding, coinciding, and guys, that just means this is a fancy word for the same line. Maybe even write that underneath, okay? It's a fancy word for meaning the same line, okay? Now, if they're the same exact line, like let's say, guys, if I take the very bottom red stripe on a flag, and I say, how many times does it intersect with this same stripe? Do they share every single point? Do they share every single spot on the line? They would. This line, this first red stripe, is everywhere the first red stripe is. It's like you're saying it's the same thing over again. Okay? So they're going to have infinitely many solutions. IMS, you guys remember IMS?
Yeah.
Okay, our old friend's back. Okay? Because they share every single point on the line.
The most American thing is teaching a class full of Americans math on American.
Right? Thank you. The only thing it'd be better if we had some apple pie right now, okay? You're disgusting. Okay.
Disgusting.
Any questions? Yes, Tucker.
If I make and bring apple pie, can you eat it in class?
No. Pumpkin pie. Pumpkin
That's
pie.
tempting for Mr. Cosso because he likes food.
It's free food. It's free food.
Yeah, it's
pumpkin pie. Pumpkin pie.
Let me think about it. I'm so tempted. I'm so tempted.
If it wasn't COVID, what would your answer be?
Oh, instant yes.
Yeah.
Not even close. That's why it's so tempting right now. Oh my gosh. Okay, Aiden. To get mints? Are you not feeling okay? Okay, yep. Okay. Our first example. Okay, we're going to do a couple more examples, right? Now we said our first step is to do what? Got them and put them in slope-intercept form. Because we need to graph these. In order to graph them, we need them in slope-intercept form. Is this first equation in slope-intercept form? No. So we need to get the first equation in slope-intercept form. 3x plus 2y equals 6. So how do I get this equation in slope-intercept form? Subtract 3. 3x, right? 240.
I just had deja vu.
2y equals negative 3x plus 6.
Sounds so weird.
Now what do I do to get y by itself? Divide by 2. 2y divided by 2 is y. Do negative 3x and 2, do those simplify? Okay, so it's just negative 3x over 2. Does 6 and 2 simplify?
3.
Yeah, to 3. So what's my m and what's my b?
Your M is
Your M is negative 3 over 2.
Yep. My m is negative 3 over 2 and my b is 3. Now, I got my first equation in slope-intercept form. What do I notice about my second one? It already is. Whoo! That's dope. Okay, so now I can graph them now. So now I need to graph my first one or my second one. You don't really care. Go ahead. No, ask me your question. I want to hear it. Yep. So I had to subtract 3x, so it stays negative. That make sense? Okay, we can't just go poof and it's over there. We have to subtract. Okay. So I have to go up 3 for mine. And then my slope, I'd go down 3 and where 2? To the right. Very good. Or I can go up 3 to the left 2, okay? And if I'm worried about being precise, I can keep on just drawing down 3 to the right 2, down 3 to the right 2. And then connect all these points.
They won't connect.
Okay?
Oh, they're making parallel.
In our second line, we have the slope of negative 3 over 2. The b of negative 1, the y-intercept.
Oh my god, that's super close.
What do we notice about these?
So parallel.
They're parallel. Now wait. What do we know about parallel lines?
They don't touch.
They don't touch. What else do we know about parallel lines?
They go on and on.
They go on forever. Both all lines do. What do we know about their slopes? The slopes of parallel lines are the same. And hey, what do we notice about the slope of these two lines? Are they both negative 3 over 2? Yeah. So should we potentially know they're parallel even before we graph them actually? Yeah, you could look and say, oh, negative 3 over 2 and negative 3, those are the same. So what's our solution?
Yes.
No way to suck it.
There's no solution.
Ours right.
Our solution is wherever they intersect, and they don't. Okay? Let's look at the second one. Y equals 1/4 x minus 2 and 1/2 x minus 2y equals 4. In the first one, do we have to get it in slope-intercept form, or is it already there?
Already there.
Already there? Dope. The second one. We need to, okay? How do we get this one in slope-intercept form? Okay? Subtract 1/2 x. What am I going to write first? That negative 1/2 x or the positive 4? Probably the negative 1/2 x. I like my x's first. Okay, now what do I do? Divide by negative 2. They're multiplying. Now wait a second. Is this creating a double-decker fraction here? Now, what did we say before about double-decker fractions? We don't like them. So what can we do instead? Multiply by something else. What can I multiply by? The reciprocal. I can multiply by 1 over negative 2, can't I? And I can do this entire side by 1 over negative 2 and then distribute it. So on the left-hand side, if I put this 1 over 1, the negative 2y over 1, what happens with the negative 2 and the negative 2? They do what? We reduce.
I haven't said that in a while.
Y equals, now we have to distribute. So it might be helpful for us to write some of this off to the side. We're doing 1 over negative 2 times 1 over negative 2x. Think of Mrs. Haswell. So negative 1 over 2x times negative 1 over 2. When we multiply, we do it left to right, straight across. So what's negative 1 times negative 1? Or negative 1x times negative 1?
Bye.
What's negative? You want to give them the worksheet. It's the 4.8. Negative 1x times negative 1 is what? Positive 1x. Over what's 2 times 2? 4. So y equals x over 4. And we have 4 times negative 1 over 2. It might be helpful for us to write that off to the side as well. 4 times 1 over negative 2. What was that?
Which one is it?
It should be the one right below that hot pink one.
Oh, there we go.
My classes are off from each other right now because the even's getting behind today. I'm losing a day. So we can put this 4 over 1. What could we do before we even multiply to make our life easier? Cross reduce. And what goes into both 4 and negative 2? 2. Goes into 4 twice, goes into negative 2 once, so it's a negative 1. Multiply straight across. 2 times 1 is 2 over negative 1. Is that the same thing as just negative 2?
Yeah.
2 divided by negative 1? That's the same thing as negative 2. So y equals x over 4 minus 2, right? Does that make sense, or do we need to go back and explain that?
No, that makes sense.
That makes sense.
Okay, I'm seeing some yes, I'm seeing some no's. Let's go back and explain this, okay? So we subtract 1/2 x to start. Then I said, okay, well, I have negative 2y. If I divided by negative 2 everywhere like we normally would, that created a double-decker fraction somewhere in there. We said, whoa, we don't like double-decker fractions. That's confusing. We don't know what to do with it. So I said, okay, Well, instead of dividing, we can always multiply by the reciprocal. Okay, you guys remember that? Instead of dividing, we can multiply by the reciprocal. So we multiplied everything by the reciprocal, and that was 1 over negative 2. Reciprocal of negative 2 is 1 over negative 2. So we multiplied everything by it. So on the left-hand side, we just got y. On the right-hand side, we had to distribute. So I did that off to the side in orange. And we end up getting x over 4, or 1x over 4. And we ended up getting negative 2.
Huh?
Questions on that? Does that make more sense? Does that make more sense? Okay. I just re-explained how we got to the green. Did you understand it the first time?
Yeah.
Okay, you're good. Okay, so let's graph these lines. What's this first line? Let's go ahead and graph that.
Negative
What's the M?
Oh, 1/4.
What's the B?
Two.
Negative 2.
Negative 2. Let's graph. So where do I start? I go where to?
Negative 2 down 2.
Down 2. I begin with B.
Because it's the same.
And I go up 1 over 4. Down 1 to the left 4.
Quit laughing.
And I connect these. Tell me to quit laughing?
No,
Oh,
It's the same line.
okay. Wait, what? It's the same line.
Slope.
My M is 1 over 4. But they're the same slope. Shouldn't they be parallel? Why are they on each other?
they're double decker.
Because it's the same exact equation. It's the same slope and the same y-intercept. On the first one, we have the same slope, different y-intercepts. So they're parallel. Here, same slope, same y-intercept. So they're coinciding. These are the same line. Now, at first, did it look like they were the same? Even halfway through, it didn't look like it was the same. So a lot of times, they hide themselves to make it not look like they're the same, okay? Oh, so what's our solution here? IMS. Everywhere on either of these lines is on both. Okay, not the same. Okay? Aiden.
Okay, the flag thing.
The flag thing, I'd be like, that's the bottom red stripe, and I say, okay, so let's do this red stripe, and I tell you to do the farthest right red stripe as well.
All the way over.
Well, that'd be the same thing. Okay? Questions on this at all? Okay. So I know we said we called it 4 steps. Really, it's really not. You just have to graph the lines, and you find where they intersect. You graph lines, you find where they intersect. But in order to graph the line, you need it in the slope-intercept form. Okay? Does that make sense? Okay. We will have a worksheet because I am a big meanie head. Ms. Hazel, would you like to pass out this worksheet to everyone?
Let's go outside.
Yeah, can we?